In the vast, desolate plains of Kazakhstan, there lies a place of immense power and possibility. This is the Baikonur Cosmodrome, the world's first and largest spaceport. For decades, it has served as the launchpad for humanity's greatest adventures beyond Earth. Why Kazakhstan, you might ask? Baikonur's location offers a unique set of advantages for space travel. Its inland position provides a large safety margin for rocket launches. The flat, open terrain allows for clear tracking and communication with spacecraft. And its southern location means rockets get an extra boost from the Earth's rotation. It was from Baikonur that Yuri Gagarin, the first human in space, launched into the unknown. And it is from here that the Soyuz rocket, a workhorse of the space age, continues to carry astronauts to the International Space Station and beyond. The Soyuz rocket is a marvel of engineering, a symphony of power and precision honed over decades of use. Standing tall on the launch pad, it is divided into 3 distinct stages, each with a crucial role to play in the journey to space. The first stage, the largest of the 3, is a cluster of 4 conical boosters strapped around a central core stage. These boosters are fueled by liquid oxygen and kerosene, a potent combination that provides the initial thrust needed to overcome Earth's gravity. The second stage, much slimmer than the first, takes over once the boosters have exhausted their fuel. It continues to propel the spacecraft higher and faster, pushing it closer to its orbital destination. Finally, the third stage, a small but powerful engine, provides the final burst of energy needed to reach orbit. It is this stage that delivers the Soyuz spacecraft, carrying its precious human cargo, into the vastness of space. The moments leading up to a Soyuz launch are filled with anticipation and tension. Years of training, millions of calculations, and the hopes of countless individuals rest upon the success of this single event. Then, the command is given, and a fiery inferno erupts beneath the rocket. The ground shakes, the air crackles with energy, and a pillar of fire shoots into the sky, illuminating the Kazakh steppe. The roar of the engines is deafening, a visceral reminder of the immense power being unleashed. Slowly at first, then with increasing speed, the Soyuz rocket rises from the launch pad, battling against the relentless pull of gravity. Inside the capsule, the astronauts are pressed back into their seats, experiencing the full force of their acceleration. Up and up it climbs, a beacon of human ambition piercing the heavens. The Earth shrinks below, becoming a blue and green sphere against the blackness of space. The journey to orbit has begun. Spaceflight is inherently a risky endeavor. Countless things can go wrong during launch, from engine failures to structural problems. That's why the Soyuz rocket is equipped with a sophisticated launch escape system designed to protect the crew in case of an emergency. Perched atop the Soyuz capsule is a tower resembling a pointed hat. This tower houses a powerful solid-fueled rocket engine, ready to ignite in an instant. Should a major problem occur during launch, this escape rocket will fire, pulling the capsule away from the malfunctioning rocket. The escape system is designed to function automatically, triggered by sensors that constantly monitor the rocket's performance. It can also be activated manually by the crew if needed. Once the capsule is a safe distance from the rocket, parachutes will deploy, guiding it gently back to Earth. While the Soyuz launch escape system has been activated several times during its history, thankfully it has always functioned flawlessly, saving the lives of the astronauts on board. It is a testament to the emphasis on safety and crew survival that underpins every aspect of the Soyuz program. Section 5. Parting Ways. Stage Separation in Space. As the Soyuz rocket ascends through the atmosphere, it sheds its weight stage by stage like a snake shedding its skin. Each stage separation is a carefully choreographed ballet of pyrotechnics, thrusters, and precise timing. First to go are the 4 side boosters. Once their fuel is spent, explosive bolts sever their connection to the core stage. Small separation motors push them away, allowing them to tumble back to Earth, where they will land safely in a designated drop zone. Next, the core stage, now empty and its role fulfilled, detaches and falls away. The second stage ignites, taking over the task of propelling the Soyuz higher. This stage too will eventually be discarded, breaking away once its fuel is depleted. Finally, only the third stage and the Soyuz spacecraft remain, hurtling towards their destination in the vastness of space. This process of stage separation, while seemingly complex, is crucial for achieving orbit. By shedding unnecessary weight, the Soyuz rocket can achieve the high speeds needed to escape Earth's gravitational pull. Section 6. Dancing with the Stars, Reaching Orbital Velocity. Reaching space is only half the battle. To stay in space, the Soyuz spacecraft must achieve orbital velocity, a speed fast enough to counteract the Earth's gravitational pull. This delicate dance between gravity and velocity is what keeps the International Space Station and other satellites in orbit. The third stage of the Soyuz rocket is responsible for providing this final push to orbital velocity. It fires its engine in a series of carefully calculated burns, gradually increasing the spacecraft's speed and adjusting its trajectory. As the Soyuz reaches orbital velocity, a sense of weightlessness envelops the astronauts. They are no longer bound by Earth's gravity, free to float inside the capsule. The Earth spreads out below them, a breathtaking tapestry of blue oceans, swirling clouds, and brown continents. From this vantage point, the thin blue line of the atmosphere is clearly visible, a fragile shield protecting life on Earth. It is a humbling reminder of both the beauty and the fragility of our home planet. Section 7. A Cosmic Rendezvous. Docking with the ISS. Reaching orbit is a major accomplishment, but the journey is far from over. The Soyuz spacecraft must now rendezvous and dock with the International Space Station, a marvel of engineering orbiting Earth at an altitude of about 400 kilometers. The rendezvous and docking process is a complex and delicate maneuver, requiring pinpoint accuracy and perfect timing. The Soyuz spacecraft utilizes a combination of automated systems and manual control, guided by ground controllers and the experience of the crew. Slowly and carefully, the Soyuz approaches the ISS, its thrusters firing gently to adjust its speed and position. The two spacecraft draw closer, their relative velocities carefully matched. Finally, with a gentle bump, the Soyuz docks with the ISS, forming a secure connection between the two spacecraft. Hatches are opened, and the astronauts aboard the Soyuz are greeted by the resident crew of the ISS. After months of preparation and a perilous journey, they have finally reached their destination, a shining testament to international cooperation and human ingenuity. Section 8. The Long Journey Home. Reentry and Landing. After spending weeks or even months aboard the ISS, conducting research and marveling at the beauty of Earth from above, it is time for the astronauts to return home. Their journey back to Earth begins aboard the trusty Soyuz spacecraft, now their lifeboat back to the planet they call home. Undocking from the ISS, the Soyuz begins its descent, firing its engines to slow down and begin its re-entry into the Earth's atmosphere. This is perhaps the most perilous part of the entire mission, as the spacecraft encounters intense heat and pressure as it plunges through the atmosphere. Protected by a heat shield, the Soyuz capsule endures temperatures hot enough to melt metal. Outside, the air glows red hot, but inside the astronauts are safe, their descent controlled by a combination of parachutes and thrusters. Finally, with a gentle bump, the Soyuz capsule touches down on the soft soil of the Kazakh steppe, its journey complete. The astronauts emerge, tired but exhilarated, greeted by the cheers of recovery crews and the warm embrace of Earth's gravity. Section 9. A Legacy of Reliability, the Enduring Soyuz. For over 5 decades, the Soyuz rocket and spacecraft have been the workhorses of human spaceflight. They have transported hundreds of astronauts to and from space, demonstrating remarkable reliability and resilience. The Soyuz program is a testament to the ingenuity and determination of the engineers and cosmonauts who designed, built, and flew these incredible machines. It is a legacy of international cooperation, with nations around the world relying on the Soyuz as a safe and reliable means of access to space. As we venture further into the cosmos, the Soyuz will continue to play a vital role in our exploration. It is a symbol of human ambition, a reminder that even the most challenging of dreams can be achieved with courage, ingenuity, and a spirit of collaboration. The Soyuz, a child of Earth, will continue to carry us to the stars.